Okay, here's the second half of 11.3. All right, so notice we're back to cube roots. So we need to make sure when we're doing these, we have to have 3 of something before we can take it out. And so when we multiply these, that's going to give us 3, and then we have the cubed root of, now we can bring everything inside under the cubed root. That's a 4a to the 4th, and then times 10a to the 3rd. All right. Now, what do we have here? Well, 4 is 2 times 2. 10 is 2 times 5. Well, there's 1, 2, 3 2, so that's 2 to the 3rd times 5. Now, looking at a's, now we have a to the 7th. Well, remember, if we want to reduce this, we have to have even numbers, so it has to be by 3. So 2 3s is 6, so a to the 7th we can rewrite as a to the 6th times a. And so this is times a to the 6th times a. And then we have 3 times the cubed root of that whole thing. Okay, so we've kind of split it all into pieces, made it so it's the cubed root, which is what we need. And so now we have 3 here. Now this part, cubed root of 2 to the 3rd, that's going to be 2, so we can put a 2 there. Now the cubed root of 5, that's going to stay 5, so we'll leave it. Now here we have a to the 6th. Now with the cubed root, remember that puts it over, so a to the 6 over 3 is equal to a squared. And so a squared comes out, so that piece comes out. And then we still have a cubed root of that. So what we have left then inside is 5a. Now if we want to simplify, we have 2 times 3 is 6, a squared, then we have cubed root of 5a. Okay. And so then that would be our final answer, taking those 2 cubed roots and multiplying them together. All right, the next one, we're back to distributing. So we're going to take that monomial times each term of the binomial. And so when you take that, 5 times 3, that's 15. And then we have still, inside we'll have 15 times 3. And I'm going to leave it broken down like that just to make it a little easier in a little bit. And then we have this times 2. Well, that's going to be 2 times 5, which is 10 square root of 15. All right, well, what is 15? Well, that's 3 times 5. And so that one is going to help because we have a 3 times a 3 here, so that gives us a 15. And then we have a square root of 3 squared times 5. Now here, 3 times 5 doesn't help us, so we still just have 10 square root of 15. Now the square root of 3 squared is 3 times this, so that's going to give us 45 square root of 5 plus 10 square root of 15, and then that will be our final answer. The 45 times the square root of 5 plus 10 times the square root of 15. And again, we had to break this down so we knew we could pull out that square root of 3 squared as 3, and then we took 3 times 15 and got the 45. All right, we're back to binomials, so we have to FOIL. So we're going to take first times first, so that gives us a negative 2 times a negative 5, so that's a positive 10. And then we'll have this times this, our outer one, so a negative 2 times a 2 radical 3, so that's going to be a negative 4 radical 3. Now we have our inner, so we'll take this times this, so that's going to give us a minus 5 radical 3. And then here we'll take a radical 3 times a 2 radical 3, so that's going to be plus 2 radical 9. Okay. What is 9? Well, that's 3 squared, so that's really going to be the square root of 3 squared, which is 3. So this is 6. That's going to be a plus. Here we have a minus 4 minus 5, so it's going to be a minus 9 radical 3. And then here we have our 10 still. So that is what we've done. We've taken those 2 to here, and we've gone down. And now we have 10 plus 6, so that's 16 minus 9 square root of 3, and that would then be our final answer. Now you notice a lot of times when we multiply with these radicals, one set goes to a something squared, and we can get rid of that square root, and then we just have one square root in the end. Now that doesn't always happen, but sometimes it does. All right, now here we have first times first. So we're gonna have a negative 2 square root of, now we'll have 2p times 5p. We're just gonna take and leave what's in here times what's in here like this. And then we'll take our outer, so we'll take that times that, and so we're gonna have a minus 2 times the square root of. Now we'll have a 2p on the first one and a 5p on the last one. Okay, which makes sense because those are both the same, so we should get two of the same things. Now we'll do the inner, so we'll multiply these two together, so we'll have plus 5 times, and then we'll have a 5 times 5p. And guess what? When we take the last, we're going to have the same thing. We're going to have plus 5 square root of 5 times 5p. All right, so now we need to simplify. Well, what is this? Here we have a negative 2 square root. Well, 2 and 5, those aren't perfect squares, so that's going to give us 10. P times p, that's p squared. So that eventually we can take out as a square root. Now we have minus. Well, this one is going to be, guess what, the same as the first one, so that's a minus 2 times the square root of 10p squared. Now what about the next one? Those next two are going to be the same, so it's going to be 5 times the square root of 5 squared p plus 5 times the square root of 5 squared p. Okay, now let's get rid of our squared terms. So square root of p squared is p, so we'll have a minus 2p square root of 10, and then we'll have a minus 2p square root of 10 plus, now here square root of 5 squared is going to give us 5 times 5 is going to be 25 square root of p plus 25 square root of p, because those two are the same. And now we simplify, so that's going to be a minus 4p square root of 10 plus 50 square root of p. Okay, and so then that will be our final answer. And because we had different radicals, we're going to end up with 2 radicals in our final answer in this one, which makes sense. All right, now we're back to things we can simplify, either putting it under one radical or just taking square roots automatically. And so when we do this, square root of 15, well, that's 3 times 5, so you know that one is going to just stay that. Well, what is the square root of 4? Well, the square root of 4 is 2 times 2, so that gives us 4, and that's as far as we can go. That's going to be our final answer. Okay. What about this one? What is 32? Well, that's going to be 16 times 2. Okay, so when we do that, that's the square root of 2 over 3, and then it's going to be a square root of 16 times the square root of 2. Well, guess what? You know, those square roots of 2 cancel, and so we get 1 over, and what is the square root of 16? Well, that's equal to 4 squared, so that's going to be square root of 16, and square is 4 squared. That's 4 times 3, and that gives us 12. And so that would be our answer for that one. Again, sometimes you can just work it out simple like this. Other times when there's things you need to put it under one radical, that's sometimes easier. And we could have done that here as well. We could have said that this was 1 over 3 and then the square root of 2 over 32. Well, then the 2 goes in here once, it goes in here 16, and so that's equal to 1 over 3 times the square root of, and then we have 1 over 16, and the square root of 1 on the numerator is 1. The square root of 16 in the denominator is 4 times 3 is 12. So both ways work, and remember we could have split that up as that if we needed to get our 1 and our 4, and then when we took 3 times 4 we got our 12. So either way we get the same answer. All right, what about this one? Oh, this one is one that there's a lot of things I think we can cancel. So what I'm going to do is I'm going to put our 4 over 5 out in front, and then I'm going to put everything else under the radical. So that's going to be 12xy to the 10th over 3xy to the 4th, and now I'm going to change colors and I'm going to cancel. So 3 goes into 3 once, 3 goes into 12 4 times. My x cancels my x, 4 of those cancel 4 of those, I'm left with 6. And so now, what do I have? Well, I've got my 4 over 5 here. Oh, not equals, it's times. And so what do we have here? We have the square root of 4. Well, if we look on the denominator, there's nothing but 1's down here. So it's times, and then it's going to be square root of 4, which is 2. And then we have y to the 6th. Well, remember, that's y to the 6th over 2 because we have the square root, so it's over the 2. 6 over 2 is 3, so this is y to the 3rd. And so now we can multiply across. 4 times 2 is 8, y to the 3rd over 5. Okay, and that would be then our final answer. I think the same thing we could do for the next one if we wanted to. We could put it, one over the other, or however we want to look at it. But another thing is, what do I know about 64? Well, what is 4 times 4? That's 16 times 4 more. That's going to give me 64. So this is really 4 to the 3rd. So here we have 3 times 5. So there's nothing good there that we can cancel. But here, the cube root of 4 cubed is 4, and then that would be our final answer. We didn't have anything to do really other than, remember, we're working with cubes, so we have to have 3 of something, and we had 3 4s, and so then that would be what we have there for our answer. All right, well, what are we going to do here? Well, let's look at our denominator first. What do we have? Well, we have the 4th root, so we have to have 4 of things. Well, here we have 4, here we have 4, so that's nice. What are factors of 81? Well, remember, if we take 9 times 9, that's 81, and 9 is 3 times 3, so this is really 3 to the 4th, m to the 4th, n to the 4th, and we're taking the 4th root of that whole thing. So when we take the 4th root, that's going to be 3, that's going to be m, and that's going to be n, and so really this is 4m over 3m n, and when we do that, our m's cancel, and so all we get then is 4 over 3n, and that would be our final answer. All right, so that's all I have for you on the second half of the video here.